Okay, let's start off by looking at gradients of lines. So let's say we've got drawn on a set of axes. Let's say we can see a straight line, and let's say that straight line passes through a couple of coordinates. So let's say that line passes through maybe this point here at 0, 2, and maybe this point here at 3, 8, for example. And we're asked to find the gradient of the line. So what we can do is we can imagine here, if we connected these up with a right angle triangle like this. To find the gradient of the line, quite often we use the formula rise over run. So we see how much the rise is. Now this point down here, it started here at the value of 2 and ended up with the y coordinate at 8. So the y coordinate is increased by a value of +6 to go from 2 to 8. So we say the rise is the difference between the 8 and the 2, which in this case would be 6. So the rise here is 6, and then the run is the difference between the x values. So this value is at 0 and this value here is at 3. So the difference between those values is 3 subtract 0, which would give the run as 3. And we know 6 divided by 3 is equal to 2. So this line here would have a gradient of 2. Now look at the line, it's sloping that way. If it slopes that way, we'll say it has a positive gradient. And if a line slopes that way, it has what we call a negative gradient. So our line is sloping that way, so that's got a positive gradient, and the gradient is 2. If I want to form the equation of the line, y equals mx plus c is the equation of the line. Just worked out the gradient is 2, so I know it's y equals 2x plus some magic number. And then if you know where your line crosses the y-axis, which I do in this case, I know it crosses the y-axis here at the value of 2, so my line would be y equals 2x plus 2 for that particular line. Let's have a look at another one. Let's say I draw out another line. Okay, and I choose a couple of points on it. So let's say the point 1, 3, and let's do the point 4 and let's do 18. Okay, so we've got 2 points that lie on our line. So if we connect them up with our little right angle triangle like we did before, and we know the gradient is equal to the rise over the run. So let's look at our two coordinates, 4, 18 and 1, 3. So the rise is the difference between 18 and 3. So that distance there would be 15. And the run is the difference between 4 and 1. So 18 take 3 is 15. 4 to subtract 1 is 3. 15 divided by 3 gives us our gradient as +5. And we can see the line slopes that way. So that means the gradient of that line is a positive, and the value of the gradient is +5. Let's look perhaps at one which is sloping the other way. So let's say this time we've got a line going down here. Let's say we've got 2 points that lie on the line. Let's go for 6, 2, and we'll go for 1, 9. Okay, so we can see this time the line slopes down this way, so we know straight away it's going to have a negative gradient. If I write out my 2 points, I've got 1, 9 and 6, 2. So the gradient, which we usually use the letter m for, is equal to the rise over the run. So for us, the difference in the y, 9 subtract 2 is our rise. The run is 1 subtract 6. So 9 subtract 2, so I'm taking down like this. 9 take away 2, 7. 1 take away 6 is minus 5. So that's not a particularly nice value. It's just going to be minus 7/5. And it's best there probably to leave that as a fraction. You could put it as minus 1.4. You could put it as a decimal instead. So that's got a negative gradient. It's sloping downhill. Let's look at another one with a negative gradient. Pick a value here, so we'll choose a value minus 220 and we'll choose the point 4, 2. So we've got 2 points that lie on our line, so minus 220 and 4, 2. So the gradient will be the difference in the y, so 20 subtract 2 over minus 2 subtract 4. So 20 subtract 2 is 18. Minus 2 subtract 4 is minus 6. 18 divided by 6 is 3. So 18 divided by minus 6 is minus 3. And we expect it to be a negative gradient because it's sloping down that way. Now you might be asked to find the gradient of a line connecting 2 points, and maybe the 2 points aren't even drawn on the grid. Maybe you're just asked to find the gradient connecting the line, find the gradient connecting the points. So let's say we've got 2 points, we'll go for 1, 24, and the point 3, 16. So I would recommend you write them one above the other like that, and then we're going to find the difference between the y's and then the difference between the x's. So our gradient will be 24 subtract 16 will be our rise over our run, which will be 1 subtract 3. 24 take away 16 is 8. 1 take away 3 is minus 2. 8 divided by 2 is 4. So 8 divided by minus 2 is minus 4. So that's the gradient of the line connecting those two. Then you asked about inverse functions. So let's say we've got a function x maps to 3x minus 1. Might be written like that, it might be written like this, or it might be written like that. They're all different ways of representing the same thing. So this function is telling us to take an input x, to multiply it by 3 to give us 3x, and then to subtract 1 afterwards. So we're taking an input, multiplying it by 3, and then subtracting 1, and that's going to give us our output. So if we want to find the inverse function, we need to imagine putting x back through the machine in reverse order. So if we think about it, the first thing we did when we put x in is we multiplied it by 3 and then we subtracted 1. So the last thing we did was subtract 1. So the first thing we need to do is the inverse of that and add 1. Once we've done that, we then need to do the inverse of multiplied by 3, which will be divided by 3, and that should give us our output. So we started with x, we then add 1, and then we divide by 3. So the inverse function will be written like this. So x maps to x plus 1 over 3, or it's written like this, or it's written like this. Okay, so if your function is this, this would be your inverse. If your function's written like that, that would be your inverse. If your function is written like that first one, that would be your inverse function. So let's look at another one. Let's say this time this is our function. Let's write it in this form as well. And let's also write it in that form. Okay, so our function here is telling us to take our input, which is x, add 7 to that, and then divide that by 2. And that will give us our output. So the inverse means we need to put x in and put it back through the machine in reverse order. So the inverse of dividing by 2 would be to multiply by 2. The inverse of add 7 would be to divide by 7. Sorry, not divide, subtract 7. And that should give us our inverse. So x goes in, we double x, so we'd write that as 2x, and then we subtract 7. So that's our inverse. So if that's our function, that's our inverse function. If it's written like this for our function, then the inverse would be written like that. And if our function is written in this form, our inverse function would be